So like I promised, last time we looked at this algebraically, I want to look at this graphically and see what we can do graphically to solve this lovely little equation. Now, the cool thing is you got a couple of options going for you. Option one says move all the terms to one side of the equation if necessary. Well, if you look at this, we have moved it to one side of the equation. We've got everything over to one side. We're going to let this equal to 0. Now, it says graph the corresponding function and find the zeros. Well, wait a second. What does that mean? Zeros, x-intercepts, solutions, okay, roots, those all mean the same thing. But here's something that's really quite interesting here. To find an x-intercept, isn't that when y equals to 0, right? Well, look at this. Didn't we, in fact, make y equal to 0? Aha, now you see it, don't you? This originally was y, but since we're finding an x-intercept or a 0, we made this equal to 0. Now, do you remember the previous question? We know what the answer of this particular question is. We know the answer is x equals to 4. Don't believe me? Go watch the previous podcast. So we're going to use this to help us graph a little bit more. Okay, the other thing is, if we're going to graph this, let's do this properly. You know all the transformations. You know the transformations are a is 1. There is a 1 here. Your b value, of course, is 1. Your h value then here is -5. Your k value here is -3. So let's graph this thing and let's do it as accurately as possible. Okay, so there's -5 and 1, 2, 3. There it is. You know your intercept here from the equation from what we did previously is 4. So that's where your intersect is going to be, right there at 4. So you're going to draw this, boom, right through there, and it's going to look like a graph that looks like that. Okay? I know what you're saying. Prove it. Well, simple. I'm going to go to my calculator now. I've entered the equation. All I'm going to do is graph. Boom. And you can see graphically that this is 1, 2, 3, 4. There's the intercept right there. But I know what you're saying. You're probably saying, well, that looks so approximate. How am I to know that if it's actually the right answer or not? Well, here's a great way of checking your algebra. Second calc. Find the 0. Do you remember how to find the 0? Left bound, right bound. Yes, get kind of close to this thing, as close as you can. There's the right bound, boom. Or your left bound, I should say. There's your right bound there, boom. Hit enter guess, and sure enough, look, there's your actual answer that we proved x equals to 4 algebraically. Great. Awesome. Okay, so now, with that in mind, let's look at the next option we have. The next option we have is this. It says we should try to enter one side of the equation as y1 and the other side as y2. Oh, wait a second. How do we do something like that? Simple. Solve and isolate that radical. So if you think about it, if you bring this and go add 3 to both sides, you now have x plus 5 equals to 3. That becomes your y1. That becomes your y2. Throw it into the calculator, throw it onto your graph, and see what you get. Well, wait a second. Let's use our transformations idea. Well, again, a, b are 1. Your h is now -5. So you're going to start out here. That's where your graph is going to start. But don't forget, you're going to have an intersect at 3. So where's 3? 1, 2, 3. Oh, there it is. Na, 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 na. And this is where you have to do a little bit of thinking because you know that your solution is going to be 4. So the solution is going to be right here at 4. That's where the two things are going to intersect because y equaling the 3 just means a nice, beautiful horizontal line of 3. The square root of x plus 5 means you start at -5 and you go all the way out here and you should have an intersect right at that point. So you have to use a little bit of smarts in order to solve this. Well, great. How do you prove that this is going to work for you now? Real simple. Go into your calculator and put down y1, y2. Case in point, look. There's my y1, there's my y2. I'm going to graph this thing, bing, and look at that. Lo and behold, 1, 2, 3, 4, da, 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 da. It's going to give you an intersection point. This means you're not going to find a 0 now because you got a y1 and y2. You're actually going to find an intersect. So go second, calc, okay, find the intersect, which is 5 this time. Curve 1, which is, of course, the blue curve, the radical curve. Curve 2 will be the line. Boom, there's your y2. It says guess, of course, and there's x equals to 4. But be careful because, of course, this gives you a y value here equaling to 3. You know and I know, look back at this original question. If you do, there is no y. So don't give me a y. That's the biggest mistake people make. There is no y. There's only the x value equaling to 4. All right, so a couple of things we also have to note is down here. Don't forget the solutions, roots of a radical equation are the same as our x-intercepts. That's why this is usually equal to 0. Okay, because an x-intercept, y equals to 0. And since there is no y in this equation, the y value is not necessary. So it's an x value only. Lots of things to remember. Good thing we've got a simple graph going here. Let's make things a little bit more complicated and see what we can do in the next couple podcasts.